Hi, dear students. This is Harita Kasturi from PACE IIT and Medical Hyderabad. So let's go with an interesting topic of stereoisomerism, which is the most important part, geometrical isomerism. So if we have to talk about the geometrical isomerism, we need to talk about restricted rotations. As you can see, the point number one, restricted rotations. And what do we mean by restricted rotation of the bonds? Whenever we have a restricted rotation, which means my bonds, when I turn them, that will break up, which means I should not turn them, right? So example, as you can see, I think you all can see this one. So it's a double bonded figure, right? So double bonded carbon, we have double bonded carbon, and then we have four hydrogens attached to it, 1, 2, and 3, 4. So when I have such a kind of setup with a double bonded carbon, now if I have to turn them, what happens? As I turn them, these bonds will break, right? Double bond will break up, right? So this is a restricted site. Restricted rotation is a double bond. Also, you will have your cyclic structures. As you turn your cyclic structures, if you have a cyclic structure and you turn them, obviously the chain will break up, right? So you should have a restricted rotation to have your geometrical isomerism. Remember this. And triple bonds will not show your geometrical isomerism for sure. Okay, triple bonds will not show the geometrical isomerism. What will show the geometrical isomerism? Your double bonds and cyclic will show the geometrical isomerism. And what are the types of geometrical isomerism that we see here? Cis trans isomerism, EZ isomerism, which means like if I have, for example, if I have a compound saying, one second, yeah. So I have a carbon double bond carbon, and then like this I am having. This is what my compound is. Now, do you observe one thing? We have two hydrogens on one side of it, one side onto the other side, to one of the sides, and then two carbons onto the other sides. When the two same groups, it can be whichever groups, it can be the same groups. When they both are on the same sides, that is called as cis trans isomerism. This is cis isomerism. But when the two same groups, like hydrogen here and hydrogen here, as you can see, this carbon and this hydrogen and hydrogen are on the diagonal sides. As you can see, this hydrogen is diagonally located to this hydrogen. So when you have such a diagonal arrangement, this is called as trans. When two same groups diagonally arranged, it is trans isomer, geometric isomer. And when the two same groups are towards the same side, that is cis. Like for in this case, two hydrogens on one side. You can also count it like two carbons on the same side, the same thing. It is cis isomers they are. So what would be the condition? The condition is wherever is your restricted site. So this carbon double bond carbon is my restricted site, right? Onto the restricted side, if you have two different groups, then you can have isomerism. Like if I have, in case I have carbon double bond carbon, here also carbon, here also carbon, then this site will not show me the geometrical part, because this carbon double bonded site, as you can see for the blue ones, double bonded site has got same carbon, same groups on the side, then it is not right, right? Which means the double bonded carbon, the restricted site should have two different groups attached. Then it is yes, then we can see the isomerism here. So this is cis trans isomerism. Next you have EZ isomerism, E and Z, antagonon and Zusammen. So antagonon is anti-sides, two different sides. Zusammen is my same side. Now what do I mean by this? If I have two heavy groups, it need not be the same groups, but now it can have two heavy groups on the same side. Like I have carbon, carbon, I have hydrogen here, chlorine here, carbon here, and this hydrogen here. Now tell me, what is this? Is this my cis isomer or not? I say yes, it is a cis isomer, because two hydrogens, two same groups attached onto one side, it is cis. I have here carbon double bond carbon, I do have here, and that is my restricted side. To the restricted side, on to the right side, this carbon, I have hydrogen and chlorine. On to the left side, I have hydrogen and carbon. These are the two different things. two same groups on one side of the things, like hydrogen box, hydrogen box. I am writing this box as hydrogen here, and here also a box of hydrogen on the same side. It is cis isomer. Now, when do I say whether it is my E isomer or Z isomer, right? So then what do I do? So you can check it out this way. So whichever are the heavy groups, do you see chlorine is a heavy group out of hydrogen and chlorine, out of the flower bracket here shown here, out of hydrogen and chlorine. My chlorine is a heavy group, so I'm star marking this part. And out of the next, to the left side, to the carbon, I have hydrogen on the top and carbon on the bottom. Carbon is my heavy group. So if I find two heavy groups onto the one side, that is Z isomer. Okay, Zusammen is your same side. Antagonon is the opposite side. If this carbon, like I can show carbon, then carbon, hydrogen, then here I would show hydrogen there and chlorine here. Sorry, yeah. Uh, then I can have hydrogen here and chlorine here. Do you first observe that this is hydrogen on your trans side? So this is definitely my trans isomer. This I can say this as my trans isomer. Also, I can see this carbon. See, to the left side, onto the carbon, I have carbon and hydrogen, out of which carbon is my heavy side. So star on that. And then to the right side, I can see hydrogen and chlorine, wherein chlorine is my heavy side. So this one. So when my two heavy sides are on the opposites or on these diagonal kind of thing, right? I can show you this way, like diagonals here, right? I'm just trying to erase this part. Yeah, 1 second. Yeah. So you can see here the green one, this carbon, and is on the diagonal to this chlorine. Two heavy things on diagonally placed, that is your, definitely your E or Z. Z is same side. E is antagonon. E isomer, that is called as. So mainly if we have to talk about the isomers, geometric isomers, cis trans isomers is what we talk about. And then we have your EZ isomers. Now, if I have to talk about the total number of geometrical isomers, because this is very difficult to draw each and every figure. If even if you miss out on one, you're done with the answer, you will be ending up losing the marks. So, what is the trick behind it? So, you understood how to find out the isomers now, how to find out the geometrical isomers now. So, now the trick lies in showing how many isomers are there, how many geometrical isomers are there. So first we need to actually check up how many stereo sites are possible for us. Stereo sites is how many restricted bond sites, how many restricted sites. If I have a symmetric structure and if I have non-symmetric structure. If I have a non-symmetric structure, which means both the sides of the plane of symmetry, whenever I draw a plane of symmetry, the left side and right side or top and bottom, whatever it is, that has to be the same, then it is called as your symmetric sides. If it is non-symmetric, both of the sides are different from each other. So that would be, if you are having a non-symmetric compound, 2 power n becomes the number of geometric sides, geometrical isomers. N stands for the number of stereo centers. Number of stereo centers is like how many double bonds and all, wherein you have the sites. You need to identify the sites wherever we have these geometrical isomerism shown. So that we will be doing up with more number of questions and you will have a more better understanding. All right. So if it is non-symmetrical isomers, then it is 2 power n. Non-symmetrical structures you have, then it is 2 power n, where n stands to the number of stereo centers. Then you have your symmetrical. If you have a symmetrical figure, then n can be either, number of sides can be either even or odd, right? So if it is even, then you have 2 power n minus 1 plus 2 power n minus 2 by 2. These many number of isomers, geometrical isomers you are going to get. And if it is n odd, then 2 power n minus 1 plus 2 power n minus 1 by 2 odd number of isomers. If you have odd n as odd, n stands for your stereo centers. If that is odd, these many isomers you are going to get for n is odd for symmetric structures. All right. So by this, I think a small understanding of your geometrical isomerism you all got. Now, what is that we are going to do? We are just going to do attack on some of the questions now from your past papers and all right, so that you will have a more understanding on the topic. Let's hit on to the topic now, right? So, which of the following compounds, the very first question here, which of the following compounds are going to show geometrical isomerism? So, the main important point for geometrical isomerism is find out the restricted sites. And then if you have onto the restricted carbon, are you having two different sites or not? If you check that, then you're half done. All right. So, triple bond, as we have just now seen in the, conditions for geometrical isomerism, triple bonds will not show. So triple bonds are not going to show that. So option 1 wrong. C6H5N2. So how do we go with C6H5N2? You have two C6H5s and two nitrogens. So N double bond N, and then here a C6H5, which is nothing but my phenyl. Okay, this is also my C6H5. This is my phenyl, and nitrogen will have a lone pair associated with it. Yes. So nitrogen, two nitrogens and two phenyl groups. So definitely my lone pairs, please do consider lone pair also as a bond. All right. So I have my restricted site here. My double bonded site is the restricted site here. I am just showing you in the blue. Double bonded site is the restricted site. And onto the double bonded side, to the right side nitrogen, I have lone pair on one side, phenyl on one side. Very good. Two different groups. Left side also check up, lone pair on one side, phenyl on one side. Very good. So it will show geometrical isomerism, and this is cis isomerism, because whatever I have drawn here is on to the same side. Now I can do the same thing for the same question. See, nitrogen double bond nitrogen. I can show one lone pair here, and the same thing. The on left side I'm not changing it, bache. Left side I'm not changing it. Right side I am changing it to be my phenyl group like this, and lone pair onto the other side. So do you see this as trans? Do you see this as trans, right? So this is cis and that is trans. On the opposite sides, you have those, two similar groups on the opposite ends, that is trans, two similar groups on the same side, it is cis. But the condition is onto the restricted side, whatever two groups attach it to the carbon or to the nitrogen, whatever it is, it have to be the different groups. They have to be the different groups, which is, yes, lone pair is different from phenyl group, so then it is. So option B is showing. Now let us also check why C is not showing them, right? So you have double bond. This is a cyclic structure. Cyclic structure, you have Cl. Okay. After that, you have a carbon. Here also Cl, right side, you have a Cl. After you get a carbon. And here is the point which is in contact with both of the things. Like when you go from the left side, you are moving like this. Right side also you go, you're moving like this, you are entangling, you are actually encountering one single carbon, not a bond. When you encounter a bond, it is fine. When you're encountering a carbon, it is not, you're not able to break that part, right? So therefore option C wrong. And then why not option D? Also let us check it out. Why not option D? So because that is where we need to check up. See, double bonded carbon site, I can see this star mark, I'm putting it here, star. Okay, on option D, star. Nitrogen will have one lone pair, definitely I'm drawing that lone pair. So one of the sides, yes, one lone pair and one OH, very well, very good. And then the other side here, it is the carbon. Carbon ke on to the right side, you have phenyl group with CH3. On to the left side, also phenyl group with the CH3. Same groups you have. So therefore, geometrical isomerism doesn't exist here. Geometrical isomerism exists only if you have two different groups onto the restricted site. Remember that. All right. So option B is my answer here. All right. Next question. Move on. So everywhere, wherever you want, you can just pause the question and then go for it. Bacha, remember it. All right. Yes. Moving on for the next question. Um, which of the following will show geometrical, no? Yeah, so chlorocyclopropane, cyclopropane is this one, and this is one chloro. Is this site exhibiting? I would say no, because see, chlorocyclopropane, this is the site. Cyclopropane, I would say this is the site. Here is a hydrogen, here is a hydrogen, right? So two hydrogens onto the same carbon. No, not at all. Wherever you have a restricted site पे दो जो groups होते हैं, उनके लिए you should have different groups, but these are both the hydrogen groups, so definitely not. And here check out for this question also. Then in that case 1,1,2 trichlorocyclopropane. Chalo, let us draw that first. Always draw and check. Okay, trichlorocyclopropane. Okay, it is a cyclopropane. 1,1,2. 1,1. Okay, trichloro. 2 also chloro, cyclopropane. So where do I see my GI there? So here definitely no. Okay, so this position to whichever position I talk about, to this position, obviously I have failed out in the first step only, 2 chlorines in one step. No, not at all, right? So this also will be wrong. Then hexachlorocyclopropane, all of them are chlorine, all of them are same groups, definitely not. So my only option left out with me is D, right? Now also please check why is D correct answer. Please check why is D correct answer, because as you can see 1,2 dichlorocyclopropane. Okay, cyclopropane 1,2. So obviously this will be high H and this will be H. So yes, you have a group here. C and H are different groups. Then my stereo center is here and here. This is one center. Green points I have dotted. So this is the site wherein that is my restricted site, and two different groups definitely I do have here. Two chlorines on one side, I would name this as cis, and one chlorine on the opposite side. If you turn one, you hold one and turn the other, then it will be my opposite one, which is trans one. Okay, next number 3, moving on to number 3 there. Yeah, so 2-phenyl 1-butene. Always draw 2-phenyl 1-butene. So I would just make them ready for you, and then we will check everything. All right, or you please pause the figure and then keep doing everything, and then check out which has not. Question number 3A. 3A, I'm drawing it here in the green. Okay, 2-phenyl, 1-butene. Butene, and this is 1-butene, 2-phenyl. On the second position, you have a phenyl group. I'm just writing it as PH. Okay, so 1-butene. So check out. So this is hydrogen, that is hydrogen. Definitely not. So option B. So here we have two hydrogens coming up on one side. So no, not at all. So 1-phenyl, 2-butene, 1 and oh, 1 second. Did I draw butene or what? Oh, I'm so sorry, bache. 1 second. Yeah. Where's my eraser? Yeah. Yeah, still it will not be the right. Yeah, so butene, 1, 2, 3, 4. Butene this is, and 1-butene and 2-phenyl. On the second position, you have a phenyl group. So definitely on to the last carbon, onto the terminal carbon, you have two hydrogens definitely, which we are not showing, but yes, it is two hydrogens there. So definitely your thing will not exist here. When you have on the restricted side, two same groups you have, it will not exist. So option B pe check karo. Why is option B right or not? Let us check that. Please draw the figure every time and then check. Okay. So option B, 1-phenyl, 2-butene. So first position you have phenyl, but 2-ene. Yes, I can see my restricted site. Double bond is my restricted site, onto which one hydrogen and the other is this group. And left side also, as you can check out, one is hydrogen and other is this group. This is my trans site. Yes, it is showing. Why trans? Because they go hydrogen and hydrogen diagonally placed. Right side you have two different groups. Left side you have two different groups. Very good. You can please cross check why C and D are not. You will cross check and let me know. All right. Next. So option B is right for this. And then question number 4, compound X can exhibit isomerism. Can exhibit which kind of isomerism? Let us see where is my restricted site. Here is my restricted site. This is my restricted site, onto which right side CH2Br and CH2Cl. Yes, two different groups. And to the left side, what do we have? Left side, dekho, one is the hydrogen, other is all this big group. Yes, two different groups here also. See, if you have carbon, double bonded carbon A, B, C, and D, then yes, very well, it is exhibiting. Okay, so therefore it is geometrical isomerism. Tautomerism and all, we will be dealing with tautomerism also in the next session. Don't worry, let us first focus on the geometrical isomerism part. All right, next, geometrical isomerism is possible in which of the cases that has been asked. So wherever I see a double bond, I will just go on starting with the thing. So here I can see a site. Okay, left I go and to this portion I come, and here also I'm coming up with black here, and here I'm encountering on one carbon. So definitely not. You should encounter at half of the bond, onto the bond. So if you're encountering onto the one carbon, no, not at all. Okay, and here this is my restricted site, and then you have one, two, okay, three, four. Okay, when you're coming on to this part, you have CH3 and CH3 here, definitely not, right? And here also double bonded things and double bond in enes, I would say C. So whenever you have double bonds in ene, if it is less than 7 carbons, you will not consider it. Double bonds in enes, you can just follow it as a tip. Double bonds in ene, if your cyclic bond, if your cyclic bonds and ene cyclic bonds, if it is less than 7, you will not consider it for your geometrical isomerism. So not here also. It is 6 carbons with a double bond. No, not at all. Here, yes, you have more number of carbons. Yes, you will consider this. All right. So this will be my answer there. Next, which of the following can have, you can write them as a tip also. Which of the following can have two different arrangements in space? Which are two different arrangements in space? So here and here, one is the CH3 group, the other will be hydrogen only, right? So yes, this will have the two different arrangements. And whenever you have in the cycle structure double bond, you will not consider it. You will not consider it. Okay, so B and C, I'm not considering it. And if this is the site and this is the site, two CH3 groups onto the same carbon, restricted carbon, no. Here also two hydrogens onto the same restricted carbon, no. All right, so option 1 is my answer. Option E is my answer for this. Next, dipole moment is shown by which of the following? Dipole moment is shown by what? 1,4 dichlorobenzene. Dichlorobenzene is what? Benzene, it is 1,4 dichloro. It is onto the top and onto the bottom. You have two same groups. So dipole moment, net dipole moment is 0 here. Okay, then you have trans 1 chloro, prop 1 ene. Propene 1, 2, 3. Okay, this is my propene, and trans 1 chloro. So it is on the position, it is trans chloro. And first position pe you have chloro here. Okay, then you should have your other thing has to be your hydrogen only. Na? 1 chloro, prop 1 ene. So other has to be hydrogen. Trans बोला गया है, तो trans में तो क्या होगा? You will have the other hydrogen linked up here. Okay, this will be having the hydrogen part and the other hydrogen linked up here. This one and this one, definitely. Okay, so this group, all of this group, one second. Yeah, I will just rub it up and write it neatly for you. One second. Yeah. This one, right? So this is my chloropropene, and for this carbon, you have hydrogen and chlorine onto the right side, carbon and hydrogen onto the one side. This is my trans structure. Do I have my dipole moment here? Yes, because chlorine will be dragging the electron towards it. So therefore, net dipole I can see here. And E12 dibromoethene, also dibromoethene. So this is ethene, 1, 2. E is antagon. So dibromo, we are there and we are here on the opposite side. One hydrogen and one hydrogen. Here the net dipole will be 0. Bromine is pulling from the top, pulling from the bottom. So net dipole is 0 here. Same for this as well. So enes, allenes. Yeah, okay. So this also will not be. It is, the very symmetric structure you have. It is not. So option B is my answer there. Next question number 8. The given compound is respectively isomeric with 1, 3, and 4 as what? What is the given compound? Where is the given compound? Where say? One second. Hmm. Yes. Now I can see these things. Just let me see first the restricted side. Where do we have the restricted sites? For the second question, I'm just checking out carbon to double bond nitrogen I have. So nitrogen पे one तो lone pair होगा ही. Okay, I have this one. And similarly for the fourth question also, see one lone pair and oxygen on one side and phenyl CH3 and benzene on the other side. I can have this benzene ring, phenyl ring and your lone pair on the opposites. Okay, phenyl and lone pair on the opposites, which is trans. Here also the same way, देखो phenyl and option 2 में option 2 is the same thing, phenyl and the your benzene ring on the opposite side. So I would say these two are same structures, isn't it? These two are the same structures. Then you have OH and O. डबल बॉन्ड O सिंगल बॉन्ड एंड नाइट्रोजन पे पॉजिटिव आ जाएगा. नाइट्रोजन पे पॉजिटिव आते ही नाइट्रोजन विल ड्रैग, ऑप्शन 3 पे देखो. ओके, नाइट्रोजन विल ड्रैग द इलेक्ट्रॉन फ्रॉम द हाइड्रोजन, हाइड्रोजन H प्लस बन के बाहर, बाहर जाके ऑन टू द O माइनस. So this fellow gets a negative and this drops in, which means carbon double bond nitrogen. Then single bond OH बन जाएगा. Right side you have a phenyl group and bottom you have phenyl with a CH3 group. So which means this structure, option 3 and 2 are your tautomers. Option 3 and 2 are your tautomers there. Okay, so 3 and 2 are tautomers. I think we have some options given to us also here. Yeah, so option A is what it has been asked to us. So functional groups, tautomers, and this. So yeah, my 1, 3, and 4 will be what they said. So what is my 1 here? So 1 here is carbon double bond O with NH, and this definitely will be my functional group change. So you have a double bond O onto the carbon here, right? So which means your carbon double bond O and NH groups. That is amide group given to me in the first question, and rest of them are not your amide groups. So therefore, the first one is my functional isomer. Then as you can see, second and third are your tautomers. And then you can see second and fourth as your identical isomers. This is what we have just now drawn. Okay, second and fourth are your identical things. Do you notice that? Yes. So because it is the same, trans mein hi hai, it is the same figure. Please pause the thing and then you go back if you are not clear with. All right, next, which of the following do not have geometrical isomerism? Will not have geometrical isomerism. As I said, if you have, the symmetric groups, enes you will have, enes will be showing definitely, but enes with the symmetric number will not show because you should have a plane of symmetry. Here also see, 1, 2, 3, 4, 5 enes together. This is my plane of symmetry. So these two are not showing, whereas B and D will show because this is the plane of symmetry which I can see there. It's not symmetric although, but yes, carbon to carbon, double bonded carbon, you should have some plane for it. So on now this is my restricted site. On to this, I have these two, and to the left side also I have. So B and D are my answers. Which of them will not have the geometrical isomers? A and C will not have any geometrical isomers. A and C will not have. B and D will have because they do have that plane on the bond. So plane should be there on the bond. Remember this. So remember, if you can go back to the previous questions, if you both are coming from the cycle, you're coming on to the same carbon and encountering the same carbon, then also you will not have the geometrical isomers. Okay, next question, number 10. On to the number 10, which of the following compounds will have geometrical isomers? Will have. So now, whenever I see some kind of, planes and all, we need to just check up with what are all these. See, this is benzene ring. Benzene ring is 3 double bonds. As I told you already, whenever you have double bonds onto it, into a 6-membered ring, then it will not show. So although it is methyl with the hydrogen, you will not have the fourth one here at all, because see, this is benzene ring, right? So please try to draw this first. This is my benzene benzene ring, and then one is my methyl group and one is my ethyl group. So this and this, it is done. This is what? This is 1, 2, 3 sp2 hybridized. Although it is sp2 hybridized, what is that you are having here? You have a double bond here and only one. You should have one other left out group there, right? So you don't have it here. So here what? Here nothing at all, because this bond is already occupied with four bonds, right? So therefore this site is not showing. Option A is not showing. Similarly, option C also will not show. And how about option B? Option B also, all these carbon to carbon, just check whether you have a plane of symmetry. And also, as you move on to the right side and on to the left side, you should have two different groups attached there. So option B also will be wrong there, because to the left side and to the right side you go, it is the same structures as I'm following there. So it will be definitely no. So this is identical. Identical you will get there. And then option D to correct. Option D can show which of the following compounds will have a geometrical isomers. This will show the geometrical isomer in this position. Definitely this is my restricted site, restricted position, wherein I can show you the geometrical site there. All right, next, move on. The next question, question number 11. On to the 11, which question says, which of the following compounds have a geometrical, no, not the question. Yeah. So what are these and these two figures? This figure and that figure, option A and option B, what are they? So whenever you have the sites, please check up the site. So on this site, you have CH3 and H. Okay. And on this left side also, you have this. So if these both are fixed, CH3 and H, here also see CH3 and H. So one side you fix it and other side you rotate it. Okay, then they are your geometrical isomers. See, check out to the other side. You have bromine on the top and hydrogen onto the bottom. Here, bromine on the bottom, hydrogen onto the top. So they are definitely geometrical isomers. One side you fix it and try to turn the other side. Then the other side will be the other geometrical isomer. So option B, geometrical isomers they are. Which of the following compounds will exhibit the geometrical isomerism? Draw their geometrical isomers as well. All right. So this is CH2. First option check karo. First option, this is CH2 with a double bond. This itself is a flaw, right? Because onto the restricted carbon, you should have two different sites, but here you don't have two different sites. So option 1 is wrong. And then for my question number 2, check up whether this is yes or not. Let us check. So this is my restricted site. Carbon, double bonded carbon. You have hydrogen, hydrogen, and then CHO here, and then a phenyl group. C6H5 is my phenyl group here. So yes, this will show. This will definitely show. Okay, why this will show? Because two different groups are assigned on to the restricted carbon. You can see these two are different, these two are different. So yes, they are showing. This is my cis isomers. When I hold left side part and twist the right side part, then CHO on the top and H on the bottom. I can just flip like this, CHO on the top and H on the bottom, and left side fix it up. Then it is trans. That is what is called as trans. So option B will be showing. Next, option C also check up. So this is my restricted site. Nitrogen pe 3 bonds. You will have one lone pair on the top, one lone pair on the bottom top. So restricted site, as you can see, for the restricted site, when you have two things on the top, see here, check these to be maybe the lone pairs onto the nitrogen, these two lone pairs, and right side and the left side. You have yes, two different groups, and this is also yes showing. So now once fix it onto the left side and turn to the right side. The second one you turn it, flip it. Then your lone pair will come on to the bottom, and this group, all this group will move on to the top. Now I'm just trying to assign for this much more clarity. What I would do here is I'm just writing A, B, C, D so that you will be more understanding maybe. Okay, lone pair you have, here also a lone pair you have. Okay, all this set is my A, and all this set is my B. Okay, now check up how I am drawing. because you should be very fast in drawing these things, so you will not keep on drawing everything together, right? So nitrogen, double bond nitrogen, lone pair with B, and then lone pair with A. That's it. This is my figure. So lone pair with A and lone pair with B, you have two different groups onto the restricted side. Very well, geometrical isomerism exist. And one side you flip, one side you fix it. इसको fix कर देंगे. Okay, fix to the left side, and right side you flip it up. So क्या हो जाएगा? Right side पे you will have A onto the top and lone pair on the bottom. Yes, that is another isomer. That will be my trans isomer, because one on the nitrogen top here and B here. You are fixing it. Now this is fixed. This is not changing. So therefore, you have these lone pairs on the opposites, which is my trans there. So cis and trans exist. So option C, yes. Option B, yes. And here also check out for the option D there. So D here is no triple bond दिख रहा है, तो triple bond definitely not. No triple bonds. Do not encourage triple bonds on for your this part, because that is sp hybridized, will not show. Okay, then you have double bond here again. Let us check whether this has lone pair on one side. All this my A. Okay, CH on one side, all this is B, and H is my one side. So yes, this will be showing, right? So this will be showing double bond you have, and then one side A and one side B. So that will definitely show your geometrical isomers. Now, if you go up to your option number 4, check out with your 4 there, whether we are getting the isomers or not. Yes, A, B, C, D, sites and all, check up and see all this. See all this and this. This is my A, this is my B. Okay, and this would be my C, and this would be my D. So this also will show, देखो, see, onto the restricted side, two things should be different. That's the only thing. It's not that, left side and right side different hai ki same hai, doesn't matter at all. On to the double bonded carbon, you should have two different sides. Yes, C and D are two different sides only. Although I would say this as A and B only. Chalo, A and B ही बता देंगे. देखो, carbon, double bond carbon, you have A here, B here, A here, B here. Yes, it is also geometrical isomer. You can fix left side AB, right side AB को twist करो. Then you have trans isomers there. So yes, it will be showing. So then what about my G part? G, is that showing or not? Check out the restricted sites. These are the dots which I'm showing there. Methyl with hydrogen, methyl with hydrogen. Yes, methyl and hydrogen are two different things. And here I am coming, here I am coming, here I can see a difference. I'm not encountering. See, this is a cyclic structure. When you go from the site, I have a site here. From the site I'm moving on, from the site I'm moving on. When I move on to both the sides, when I'm encountering one carbon, then geometrical isomer does not exist. I'm not encountering one carbon here. I have this bond breakage here seen. So therefore, G also will be showing. This fellow, H, will not show, because methyl, methyl, same groups, will not show. Okay, so H will not show. Even if one thing is not showing, that will not show. Okay, then I part, check up with the I part, CH3 and fluorine here. Okay, so fluorine there on, and that is one part, and to the bottom part left, and to the bottom. So fluorine is different, this is different. So, and as I move on, I'm encountering two different things there. So yes, definitely my I will be showing. Whenever you encounter different groups, yes, you will have. Then you can see that part also. You have your double bonded carbon. Double bonded carbon pe you have all the double bonds and all. So definitely not, you will not see. And then here also, as you can see here, double bond in the cyclic structure. In the carbons less than 6 carbons, if you have double bond in the cyclic structures, you will not show geometrical isomerism. All right, so that is how it is. Next, moving on, corresponding to the molecular formula, write the structural formula of these isomers which can exhibit geometrical isomers. Please draw each and every structure and check up. Bacha, I want you to draw each and every structure and check up. Okay, next comes up with your finding the number of geometrical isomers, for which I have already given you a tip, a formula wherein you can directly use the formula, because such big structures, if you keep on drawing the isomers, it's going to be very difficult. Even if you miss out on one thing, you're done. So you will not miss out on anything. You will keep on drawing each and every figure and then check it up. Okay, you will keep on, you just find out the isomers and then put in the formula. That's it, you're done. Okay, let's hit on with the question number 3. So as you can see your question here, so just identify how many stereo centers are there. What do you mean by stereo centers? I mean my number of restricted sites. How many restricted sites are here? So just check it up. This is one restricted site and this is another restricted site. We have two restricted sites. We have two double bonds here, two restricted sites. And are they both exhibiting or not? Check out. Yes, this is C2H. I'm just showing you like this, CH, and then here also CH with all this group. Yes, this will show, that also will show. And this is not a symmetric structure. If you have non-symmetric structure, then 2 power n, which means 2 square, which is 4 is your answer here. You remember that non-symmetric 2 power n. If it is symmetric, then you have either even number of numbers of stereo centers, or you will be having odd number of stereo centers. If you have even number, it is 2 power n minus 1 plus 2 power n minus 2 by 2. If it is odd, 2 power n minus 1 plus 2 power n minus 1 by 2. That's it. You will be done with your answers. So option 2, check up with your option 2 there. Second question. So how many stereo centers do you find here? I can also definitely find this is one stereo center double bond and a cyclic group also. See this what? I can see a cyclic structure here, a double bond, a single bond here with hydrogen, hydrogen and all these things. So 2. Here also it is not a symmetric structure. So 2 power n, which is 2 square. This is 4 again. Next for option 3, how many do I see? So here definitely one stereo center. I can see carbon to double bond carbon. And this is hydrogen there. Left side it is fine. Right side also, if I put hydrogen there and all this group is considered as one. So therefore, yes, there is one stereo center there. And also another stereo center I can see here in carbon double bond nitrogen. So because nitrogen, whenever I see here, nitrogen one lone pair also will be present, which we need to understand if hydrogens are not given to you and all. So you don't need to worry about that. You will have to fill it up and then check. And nitrogen 3 bonds you're going up with. So you will have a lone pair associated with it. So therefore, one stereo center here definitely. So you have two stereo centers. 2 square is equal to 4 is my answer then. And for option number 4, is that how many centers do you find there? Check out with your centers there. Option 4, do we do have here one and here one. So therefore nitrogen, देखो lone pair and lone pair, please draw the lone pairs also. And this is hydrogen and hydrogen. So it is not a symmetric thing. Again 2 power 2, which is 4 again. Not a symmetric 2 power n stereo centers, two stereo centers wherein I can show my GI here. All right. Next, moving on with, I can see something symmetric here. Do you also see the symmetric part? See chlorine, carbon, 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 chlorine, carbon, carbon, carbon. Yes, this is a symmetric structure and I have a bond wherein I can break that bond there, right? I should not break that bond, but I'm just showing you that way, right? Right. So yes, it is a symmetric thing. And how many stereo centers do you find? Here here 1 and 2 and 3. So here I can see it as n equals to 3. Matlab n is odd. If it is odd, the answer is 2 power n minus, here I should go. Okay, if it is odd number, okay, I'm going up with this. N is equal to 3, substitute here, 2 power 3 minus 1, which is 2, plus 2 power 3 minus 1, which is 2 by 2, which is 1. So this is 2 square plus 1, this is 4 plus 2, answer is 6. So here I'm getting 6 isomers totally. And then for the next one, question number 6 also, just try to identify where are all the stereo centers. All these are my stereo centers. And just check out whether it is a symmetric thing or not. Chlorine, carbon, 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 chlorine, carbon, 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 carbon. Yes, I can see this plane here wherein I can break the bond. I should not break the bond, but I'm just visualizing it like equal things on that bond. So yes, it is. So n equals to 4 I'm getting here. So n equals to 4. Wherever I get n equals to 4, it's an even number. So I will make down this set. The green one, check out the green box I'm showing you. So 2 power n minus 1, 2 power 4 minus 1, which is 3, plus 2 power 4 minus 2, 2 by 2, which is 1, 2 cube, which is 8, plus 2 power 1, 2, which is 8 plus 2, which is my 10 answer. So question number 4, question number 6, 10 GIs am I going to get? So just check it up. Is it really possible to draw 10 figures for you in your heat of the exam. So better follow this concept. If it is a small thing, yes, you will be having some questions coming up, some beautiful questions coming up on the small thing, some twisted questions coming up. Then you can draw the figures and check up. Otherwise, please don't go for the drawing. All your questions will go on the same tip. How many number of geometrical isomers? This is what you can go. Next up, a lot. EZ nomenclature to the following. EZ nomenclature is what we have just now seen. EZ. Z stands for Zusammen. Zusammen is the same side. If your heavy figures are your same side, then it is Zusammen. Otherwise, it is antagonon. Antagonon is the opposite side. Antagonon is the opposite side. Zusammen is the same side. Now, I can see all this to be the same, right? All this to be the same. And this is my restricted side star here. Carbon, double bonded carbon is my restricted side. Triple bond is not a site, okay, of geometrical isomerism. So double bonded carbon. So this is my star mark thing is my restricted side, wherein C double bond OH is a heavy group. And then instead of having CH left side, left side you have nitrogen here is a heavy group definitely. So therefore, two heavy groups, two star groups, these two groups are on the same side. This is Zusammen. All right. Two heavy groups on the same side, it is Zusammen. And here also check out, this is my restricted rotation. Carbon, double bonded carbon is my restricted rotation. And out of right side you can have that benzene ring and the cyclohexane ring. Cyclohexane ring has got more number of hydrogens also. Number of carbon same, right? But number of hydrogens are more for the cyclic. So therefore, heavy group is the cyclic group, not your benzene ring. Benzene ring has got double bonds, less number of hydrogens. So heavy structures I want. So definitely on to the top. And here also, as you can see, option B here, I can see the heavy group here. Okay, so carbon, double bond O and chlorine is a very heavy group. So this will be my, again Z. Zusammen again I get. Okay, then you can see option C here. Then you have whichever is the heavy groups. Check out with the heavy groups. You have CH, CH3, CH. All this group is my heavy group there. And then NH2 with another two hydrogens also is my heavy group. This is also Zusammen there. And then I can see the next group also. Please check out the same way. Always do carry out whichever are your heavy groups, round it off and then check whether they are on the same side or on the opposite side. Same side is Zusammen, opposite side is antagonon. So as you can see, number D, where are your heavy groups? Just check out for your heavy groups and see whether you are getting those heavy groups on the one side, right? So for that question, where am I going on? So carbon with, so here carbon you have here and oxygen you have. So definitely this is my heavy group here. And then C double bond O and OCl. So chlorine is your heavy group, atomic mass and all if you check out. So this is also my Z isomer. Next, write the structures of the following compounds. This is Z, Zusammen, which means on the same side. 3-bromo, 2-chloromethyl, but 2-enoic acid. First, I will just check up with that. But 2-enoic, 1, 2, 3, 4. But 2 enoic acid, enoic, C double bond OH, okay, and 2-chloromethyl on the second position. This is 1, this is 2. On the second position, I have chloromethyl, methyl with a chloro group. So C carbon with a chloro group. And third position, I have my bromo group there. Okay, so third position is bromo and this is my this. Now this is my structure. Now identify your A, B, C, D there. Double bonded carbon, this is my restricted side. Bromine and carbon, this is A and this is B, I would say. Okay, and the rest of it, I would say all this to be my C and all this to be my D there. Okay, now it is Zusammen. Which are the heavy groups? Out of carbon and bromine, bromine is my heavy group, A is my heavy group. Okay, and then out of this part, out of D and C, which is my heavy group? On to the bromine, C with a Cl group, chlorine group, Cl is 35.5 dear. So that is a very heavy group. Two oxygens together, mila ke you will get only your 32 mass. So chlorine is a heavy group. And this this is my trans structure, but it is, I mean, not trans, I mean to say entegnon structure, which I have drawn now. But now I have to show this glutamine one. So C double bond C, bromine is A, right? A, B, C, D I have shown just now. Okay, A, and this is B, and then star to star on the same side. So which means C on that side and D on the bottom side. C on the top side, D on the bottom side. A pe star and C pe star, star, star. All these are the big groups. You remember that. All right. The next question, same again, antegnon question. Now, antegnon, but 2-in-1,4 dioic acid. But 2-in-1, 2, 3, 4, 2-in. I am showing here 2-in. 1,4 dioic acid. So C double bond OH. Yeah. And then another C double bond OH group here also I am showing. And this is but 2-in-1,4 dioic acid. And this is E, antegnon. So this one, other one would be a hydrogen, and here will be your hydrogen. So how do I show that again? Again, I'm just showing my C double bond. C is my restricted site, onto which one hydrogen and other this. This is A, this is B. Okay, and then this is C, this is D. I'm showing you now. So now this structure can be written as carbon, double bonded carbon. And now I want antegnon, which means heavy sides on the opposites. So option here, C and D. C is my heavy group, definitely. C is my heavy group, green star on that. And B is my heavy group, green star on that. C and D on the opposite sides. Do you notice that? C and B on the opposite sides. Okay, and then D here, A there. So that is my antagonon. The opposite sides is my antagonon there, right? So that is how we will go up with your geometrical isomerism. And this is a full detailed lecture on your geometrical isomerism. I hope you practice some more questions from your exercise and then do come up with the doubts. All right. So this is, this is 2B, 2A of your exercise. So better go with some other questions also on this. All right. So happy learning. Let's catch up with you on your next class on your optical isomerism, optical active isomers, optical inactive isomers, enantiomers, diastereomers, meso compounds. So much to come now. Exciting. All right. So let's catch up to you on that part. All right. See you and happy learning, bache.